Okay, section 7.4, linear inequalities in two variables. Suppose we have an equation, ax plus by equals c, that's in standard form, and we change the equal sign right here to an inequality, like greater than or less than, greater than or equal to, less than or equal to. If we do that, we get what we call a linear inequality. An example, x plus y is less than 2, 3x minus 5y is greater than or equal to 15. Those would both be examples of linear inequalities. The solution to an inequality, we have an x and a y. It's going to be an ordered pair. When you substitute the x coordinate in for x and the y coordinate in for y, we get a true statement. So this is just like with an equation, nothing different here. If you plug the numbers in and you get a true statement, then it's a solution. The graph of an inequality is a set of all points whose coordinates satisfy the inequality. Again, nothing new. To graph an inequality, the first thing you're going to do is replace the inequality with an equal sign, at least temporarily. You're going to graph that equation, but before you draw the line, you're going to check. If you have a less than or equal to or greater than or equal to, then you're going to go ahead and draw a solid line. On the other hand, if you have less than or greater than, you're going to draw that line as a dotted line or a dashed line. Once you've drawn the line, you're going to choose a test point. You can choose any point you want. Most people choose the point 0, 0. 0 is the easiest number to plug in, and if I have two zeros, that is two easy numbers to plug in. The only time you can't use 0, 0 as a test point is when the line actually goes through the point 0, 0. You're going to take your test point and you're going to substitute it into the inequality. And you're going to check. If you have a true statement, then you're going to shade over top of that point. If you have a false statement, then you're not going to shade over top of the point. You're going to shade on the other side of the line. Suppose we want to graph 3x minus 5y is greater than or equal to 15. First thing you want to do is pretend it's equal, at least for now. So 3x minus 5y equals 15. With an equation that is in standard form, the easiest way to graph that is to do your x and y intercepts. You're going to plug in 0 for y. So you have 3x minus 5 times 0 is equal to 15, and you're going to solve. Negative 5 times 0 is 0. 3x equals 15. I'm going to solve for x by dividing by 3. And you get x equals 5. So your first point that you're going to plot is the point 50, which is right here. For your second point, you're going to plug in x equals 0. So you have 3 times 0 minus 5y equals 15. 3 times 0 is 0. Negative 5y is equal to 15. Divide by negative 5. And you get y equals negative 3. So you're going to take that point and plot it. Now, at this point, you're going to check to see whether you need a dotted line or a solid line. So you go back to your inequality right here. Let me highlight that so we can see it a little bit better right here. Okay. Since it's greater than or equal to, the equal to portion, this line down here, tells us we need a solid line. So you're going to connect those dots with a solid line. Now if this were an equation, you'd be done, but it is not. It's inequality. So what you're going to do is you're going to choose a test point. Again, most people choose the test point 0, 0. As long as the line does not go through the point 0, 0, you can use it as a test point. If it does go through 0, 0, you have to pick a different point. It doesn't matter what point. Doesn't matter. Pick any point you want to. Just cannot be actually on the line. So this is a test point. What we're going to do is test it in the inequality. So this is the point 0, 0. My x is 0. My y is 0. So I'm going to substitute in 0 for x and 0 for y. So 3 times 0 minus 5 times 0. Is that greater than or equal to 15? 3 times 0 is 0. Negative 5 times 0 is 0. So the question is 0 larger than 15? Well, no, it's not. Since this answer was no, I am not going to shade over top of the point 0, 0. I have to shade on the opposite side of the line from 0, 0. So I'm going to shade over here. What the shading tells you is that every point that's shaded will be a solution to the inequality. So let's suppose you were check the point 0, negative 10, which is down here, 0, negative 10. If you were to test it in this inequality, you would get a true statement. So let's check it out. 3 times 0, negative 5 times negative 10. Is that larger than 15? 3 times 0 is 0. Negative 5 times negative 10 is 50, which is indeed larger than 15. Now, you knew that because it was shaded. It was shaded. On the other hand, if I were to choose a point over here, like negative 5, 0, if I were to plug that point in, so now I'm going to go up here, I have 3, I'm going to plug in negative 5, I'm going to plug in 0 for y, 3 times negative 5 is negative 15, subtract 0, and you see that this is not true. Negative 15 is not larger than 15. So this point right here does not satisfy that inequality, which we knew because it wasn't shaded. The same thing with this point, the same thing with this point, the same thing with that point. They are not going to satisfy the inequality because they're not shaded. Okay, another example, we have y is greater than negative 2/3 x. This is in slope-intercept form. We're going to think of it as being equal, at least temporarily. Negative 2/3 x. I'm going to write plus 0. Makes it easier to see the b. If the b is 0, which means on the y-axis you're going to put a point at 0. The slope is negative 2/3. So from that point that we just plotted, you're going to go down 2 and to the right 3. Okay, before we connect the dots, we have to check to see if we need a solid or a dotted line. Since we have y is greater than negative 2/3 x, it's not greater than or equal to. If it were equal to, we would do a solid line. But since it's just greater than, we're going to draw the line as a dotted line or a dashed line. Okay, now we need to do the shading. We're going to pick a test point. Again, normally we choose 0, 0 as our test point, but as you notice, the line actually goes through 0, 0, so you cannot use 0, 0 as your test point this time. So pick any other point, doesn't matter what. So randomly, I'm going to pick the point 5, 0. So I'm going to plug that number in, or that coordinate, I mean. My y value is 0. I have negative 2/3, and my x value is 5. Remember, when you multiply a fraction times a whole number, you're going to put the whole number over 1, multiply the tops, multiply the bottoms. So we have 0 is greater than negative 10 over 3. Now, it doesn't really matter what that number is, as long as it's negative. Is 0 bigger than a negative number? Yes, it is. Since that was a true statement, this is true, this is yes. Our shading has to go over top of that point that we just plotted, the test point. So we're going to shade over here. Okay, rather than stretching this out into one video, I am going to stop here. This is the end of part 1, and I'll start part 2 with this slide.